Hi guys, welcome to the world of DevOps. This DevOps series is absolutely free, and then if you like my video, please do subscribe my channel. Myself Karthik, DevOps trainer consultant, and then I do have 13 years of experience, and you can contact me on this email address. So the agenda for now is we already talked about why DevOps, the goals of automation, and then the software development practices, and then we also have seen the architecture of DevOps tools, right? So here's the architecture, how it looks like, and then it is very difficult for us to understand each and every tool, how they are trying to get integrated, and then what is the use case of each and every tool, right? So it is very difficult for us to understand. So let us actually deep dive into this. So now we have a development team, let's say. So the responsibility of the developer or development team is to actually write the code, right? So they write something called as one.java or star.java, anything. I mean, in star is nothing but any Java code that they write, right? So once they write the code in Java, and then they try to actually push that code into GitHub, right? So why GitHub? What is importance of GitHub? First of all, what is GitHub? GitHub is nothing but version control system. So we have each and every change that is being done by developer. We wanted to keep track of that, right? So any updates, any deletes, or anything that we do, we have to actually keep track of the changes. So for that, we actually have something called as version control systems. So like GitHub, GitLab, Bitbucket, all of these are the version control systems which have been used. So now that we have understood the importance of GitHub, right? So we have just understood the importance of Git to actually maintain or manage our code in one central location. Now that we have understood that, let's talk about the second phase. Second phase is like Maven. What is the importance of tool Maven? So the code that is being placed in Git is a one.java, right? So which humans can understand, right? So for machine to understand, this code has to be converted. This has to be converted. Why it has to be converted? For a machine to understand, we have to convert that to binaries, right? Ones and zeros. So in order to convert this to binaries, we wanted to actually convert this Java with a command. We do have commands like, let's say, to compile Java code, we have Java C and one.java. This produces an output called as one.class. This produces an output called as one.class. Now that you have gotten one.class, in order to execute this code, you will be executing something called as Java and one.class. So this is how we execute the binaries. So this class file is nothing but binaries, right? Zeros and ones, almost similar to that. So now in order to execute this particular code, we have a command called as Java and then one.class. So with using this, we will be executing the Java code. So now that you have one.java, it is very easy for you to actually use a command called as javac in order to compile that and then execute the code. Let's say you have got 1,000 Java files or 20,000 Java files, right? So 20,000 Java files are there, and then it is very difficult for you to actually execute each and every command, right? Like javac and then one.java, two.java, three.java, in order to actually build the one.class files. As it's going to be difficult for us to actually compile all of these particular 20,000 Java files that you have in your GitHub repository, what we have to actually find an automation way, automation tool, right? So one such kind of automation tool that we have got is for Java is called as Maven. For Java, we have got compilation or automation tool, automation build tool. We call it as automation build, right? One such tool is called as Maven, right? So using Maven, we'll be able to build the entire Java code into binaries. So now that we have taken all 20,000 Java code, and then we'll be placing that in one folder called as SRC. So SRC is one of the folder which will be placing all the Java code, and then we'll be compiling all of the code present in this particular SRC folder. Let's say 20,000 whatever code that you had gotten, so all 20,000 Java code is being placed in this particular SRC folder. And then this SRC folder is given as an input to the Maven tool in order to build the artifact. So the output, like we talked about the class files, right? Maven actually tries to compile the entire 20,000 Java files, and then it tries to build something called as flipkart.var. So this flipkart.var is nothing but your binary files, which is nothing but your binary. We call it as artifact, or we can also call it as a package. So anything, both the names are both reflects the same thing, like artifact and then the package. So it's like flipkart.var is the end output that we have gotten out of Maven. Now that you have got this particular binary being built, right? So this is the binary that is being built. Using this binary has to be deployed onto the servers. So now let's say we have gotten a list of servers like S1, S2, S3. These are the three servers that we have gotten. And I wanted to deploy all of these this artifact into these particular servers, 1, 2, 3. Now that you have got 1, 2, 3, it's easy for you to actually log into the server and then copy paste this particular content, right? Let's say you have got uh, almost some, let's say 20 servers. So now that you have got 20 servers and that too you have different environments like dev, QA, prod and stage, right? Stage and prod. So it is going to be very difficult for you to actually maintain or deploy the code into all of these environments onto different servers. So to address this, we need a automation tool. So that one such kind of automation tool is Ansible. So Ansible, we call it as configuration management tool or deployment tool, right? So using this tool, right? Using this tool, in Ansible, what we do is like we try to write something called as playbooks. Inside this playbook, we write something called as tasks. So each task represents to install a software onto the server, right? Let's say you wanted to have a Java 8, can have Java 8 being installed. And the another task is to deploy to target server on a specific folder, right? So this is how we actually deploy our code base into the target servers. So we write something called as a playbooks, and then using this particular playbooks, we try to execute them so that this actually copies the code to the target servers. So this problem, what we had gotten we were able to resolve it via a tool called as Ansible, right? So we have seen three different category of tools. One is Git. We have understood that it's just a version control system, which actually hosts your entire Java code. I mean, entire Java code or any kind of code that it versionized, like history is being maintained here. Next tool is like Maven, which is like a build tool, which actually tries to compile for the machine to understand. Right. So the third tool that we have understood was like Ansible, which is used for the configuration management to install any of the softwares, and then it tries to deploy into the target servers as well. So the fourth tool that we would like to understand is like Docker. So now that you have got different servers like S1, S2, S3 or S20, so you're not completely utilizing the resources. So that's the reason why we have gotten to world called as virtualization layer, wherein we will be installing something called as VirtualBox, VMware. So all of these softwares have been invented actually to create VMs. So there are number of VMs that can be created onto a machine. One single machine, you can actually have a multiple VMs being created. So on this S1 server, we can have a VM1, VM2, and a number of, according to the configuration that it has gotten, like CPU, based on the CPU and then RAM, we'll be creating the VMs. So now that you have got VM1 and VM2, you'll have to actually now deploy the code into these particular VMs, right? So instead of you deploying to the server, you're deploying your code into this VMs. Why? Why we need to do that? Because in order to actually save cost, instead of you maintaining 20 servers, you can maintain 10 servers because you are creating two VMs on top of one single server. Instead of wasting the resources like CPU and RAM, instead of wasting, you are trying to have come up with a virtualization layer using which you are trying to deploy it. But now if you see, there is 1.5 GB of OS is being actually copied to the VM. So it's unnecessary wastage, right? So further optimization we wanted. So from this particular era of VM, we have converted or invented or gone to an automation world called as Docker. So Docker, what it says is like it doesn't require any OS. What you are saying, like without OS, how an application or a machine can run, right? So what it says is like I'll try to make use of the underlying OS of the host machine itself. So this is called as host machine. This is called as host server. So using this host server only, I'll be able to use the OS of the underlying host server itself. So you're trying to save 1.5 GB of data here. I mean disk here. So right. So and then we can also create multiple containers. In order to actually spin up a VM, it tries to take 30 minutes, right? It tries to take 30 minutes, whereas uh, in order to spin up a Docker container, it just takes some 3 seconds. Why? Because here it is trying to take the copy of 1.5 GB and then it is trying to do a boot up of the VM, right? Here we don't, it is trying to just make use of refer the OS of host server and then it is trying to make use of it, right? So to just use it, it is trying to, it is trying to spin up very faster within 3 seconds. All right. So these are the main benefits of Docker. That's the reason why people are actually moving towards to Docker world, right? So now next tool that we are going to talk about is Kubernetes. Now that you have gotten number of, let's say you have created two containers here, right? So on this particular server, and then on the server two containers, and then on 20 list of all 20 servers, let's say you have created two each, and then we have gotten 40 servers, 40 containers. Docker containers. So in order to actually say, for example, one container has gone down, right? So in order to repair it, you have to log into the server and then have to fix that. Why what went wrong, and then what could be a reason why the container is not running. My application is down, right? All of these investigations you have to do. But if I say I wanted an automation around it, so that's where we have invented something called as Kubernetes. We have got into a world called as Kubernetes. So Kubernetes is an automation world which actually helps to manage the Docker containers. So if anything goes wrong here, we try to do a deployment. We try to do something called as deployments. Instead of we deploying directly here, we try to define something called as the deployments. We try to create something called as deployments, stateful sets, stuff like that, in order to actually create number of containers. If something goes wrong, they have something called as controllers in it, so which tries to actually spin up automatically instead of you logging into the server and then trying to repair that. So that's the beauty of Kubernetes. So that's why people actually have people are actually crazy about Kubernetes, right? So instead of you managing the containers, now the Docker containers are being managed by Kubernetes, right? So that's the beauty of Kubernetes, right? So now let's talk about another tool called as Jenkins. Now you have seen all of these automation. Now manual thing like member is trying to actually commit or push the code change to the GitHub, and then Maven by a person has to sit here and then to have to build or prepare this particular artifact, and then someone has to invoke. I mean, Ansible to do a deployment on the Kubernetes or Docker Vault or virtual machines or VMs or I mean normal servers as well. So instead of you doing all of this, right? So I wanted some automation tool which helps me to do all of these automatically. So that's where we got to a world called as CI/CD. The entire thing, what you see, what you have seen here, can be automated, right? So can be automated using a tool called as Jenkins. So Jenkins is a tool which is called as CI/CD, continuous integration and then continuous delivery or deployment tool, using which we'll be able to actually deploy our application and integrate the code that has been developed by developer into version control system. I mean, whenever he does a commit to the GitHub, automatically Jenkins actually would trigger a job and then tries to clone the code, build it, and then deploy it or invoke the Ansible playbooks, right? So all of these activities from GitHub, it can actually automate, right? So it is trying to continuously integrate the change into the when I say integration, each and every commit that is being done is being integrated into the artifact here. When we say continuous delivery or deployment, so deployment is like test environments and delivery is like it is delivering it to the end customer, so it is production, right? So when we are trying to do a deployment to the target servers, either via Ansible playbooks or we are trying to create another Docker containers via in the Kubernetes cluster, all right? So that's the importance of Jenkins. And then let's talk about Terraform. So Terraform is, let's say you have got all of these. Let me take different color. So now that you have got all of these servers, right? So here, these servers are actually being created. Let's say it has been created on, you wanted to create them on the cloud, right? Of any cloud. When I say cloud, we have got different clouds like AWS, Azure, GCP, a number of clouds. So if you wanted to create all of these servers, right? So in order to host your application, you have to have a machines running, right? So in order to create them, you wanted, uh, let's say you wanted to create it for dev environment. You also wanted to for QA environment, stage environment, and then prod environment. So for one environment, let's say you have 20 servers to be created. So we can use some. We wanted. I mean, it is very difficult for us to actually create all of these servers manually in all of these cloud or any of one of the cloud. In order to fix this, we wanted some automation, right? So in order to have an automation, how do we actually do that or deal with that? So the automation that we have is like a tool called as Terraform. So using this, we'll write a script. I mean, it's like we'll try to interact with the provider. It's called as AWS, and then we try to write something called as main.tf. So in this file, we'll just try to specify the creation of an instance, and then we have something called as a function called as count. So using this function called as count, we'll be able to specify how many number of instances you wanted to create. Let's say you wanted 20, right? So and then by changing the values using something called as tfvars, tfvar files for each environment, like we can maintain dev.tfvars. So for each and every environment, you can have this tfvars being maintained, and there is a something called concept called as state file, which can also be storing the state of the creation of the servers. So all of these 20 servers, we are actually automating with the help of Terraform with a single code. This single code can be executed for all the environments by just referring to different dev or qa.tf var files with different values. So according to that, it tries to create the infrastructure in AWS or Azure for different environments as well. All right, so this is the beauty of Terraform. I hope you guys have understood this particular tool stack and then where each and every tool has got fit in. And each and every tool is very important in DevOps lifecycle, guys. So I hope I made it clear. Thank you so much for watching this video.